Welcome to SME's AM Influencer Series, dedicated to the passionate professionals who volunteer with SME to connect the digital thread of additive manufacturing within traditional manufacturing. My name is Adam Penna, your host, leading customer engagement for our SME additive manufacturing community. My guest today is Carl Dekker. He is president of Met-L-Flo. Met-L-Flo is a contract manufacturer that provides cutting-edge product development, additive manufacturing, prototyping, and manufacturing services with technologies including extrusion-based additive manufacturing, material jetting, powder bed fusion, and vat polymerization. Also with direct metals, rotational molding, casting, vacuum forming, fiber reinforced plastics, low volume injection molding, and bridge tooling. Carl is also the current president of AMUG, the Additive Manufacturing Users Group, as well as having a history with ASTM. He was past chair of F42, creating standards for the industry. Carl, welcome.
Thank you very much, Adam. It's a pleasure to be here. I appreciate all the introduction there. I hope that wasn't too excruciating for you. So, looking forward to answering some questions for you.
Yeah, no, pleasure. I know we had talked a bit during the pandemic, and I thank you for your time during that. And now having the opportunity to sit down with you and talk a little bit about SME's new additive manufacturing initiative, and also what additive manufacturing does inside the whole manufacturing industry, which is exciting. So you're the right guy to do that with. So happy to have you here.
Well, I'll try and share what I can, but there's a lot of people that make it happen, and you're one of those as well. So appreciate the efforts.
Well, thank you. Happy to do it. And it is part of, being in this community. There's a lot of great things that are happening with people who do communicate and get out there. And we've had a lot of that going on, obviously, through the pandemic, but now things are moving forward. We've had a lot of experiences over the year, but we were talking a little bit about people's first experiences with additive manufacturing. And what was your first experience like with additive?
Mine was extremely fragile parts. It was back in the very beginning with stereolithography, and sure enough, it was the infamous, you look at it twice and it's broke, definitely applied. So being able to get some pieces, very slow process, low laser power. Again, you're dealing with computer processing power less than any of us have on our cell phones these days. Yeah. But it was still able to build a part and fairly accurate. Had some issues with it, but it's amazing how well everybody came together to advance and get past those. It was amazing tool and technique, typically referred to as rapid prototyping back then. So
yeah. And that was that one of the early. I know you have a background in casting. Was that where it was? Was that the first exchange? Was seeing something happening for a casting part, or what was going on at that time?
Well, it was one of those where you could build a part and it would be excellent for being able to give you a visual representation. But the second you wanted to try and do any functional testing, you became very limited by the material properties. So we wound up doing a lot of initial pieces to try and help people get the initial concept and understanding of what they're looking at conveyed, but then being able to take that and put into a silicone mold. And this was actually at the time where there was a bit of an advancement on the silicone molding, where you didn't actually have to do a lot of contact to set up the part. So you poured an entire block of rubber around it. This is still a lot of the casting technologies that we use today. Yeah. But it allowed you to be able to overnight make a mold that you can now start producing castings from thermoset chemistries into and be able to make parts that had material properties that were now functional. So it was a great way to get that first article, to be able to make that tool, get everybody on the same page with it, and then be able to get some units that you could actually start putting into testing and validation pieces. So it had some that literally were flown in. And sure enough, the piece would arrive nicely packed in foam, get the part, put together a mold and everything from it. Just thinking of one customer we were helping at this time. And of course, we sent some first pieces to them, and they said, "Hey, we're missing a feature here." And it was just because the part got jostled in transit on the plane that it broke a feature, and we never even saw it. So we were able to go in, modify the tool at that point, and be able to get enough of the feature that we could rebuild the function and be able to get them parts that they could actually put into service. So things then took a little while longer, and it's gotten a lot faster now. It's gotten a lot better, a lot stronger materials. So we've again seen a little bit of maturation of the technology, and that's resulted in a lot more utility. And starting to see additive really get pushed into the areas of how it can impact manufacturing. Whereas at that point in time, it was a quick way to be able to get engineering validation. Now we see it starting to grow a little bit into more functional components where you can build multiple parts off of a piece of equipment and start using that to do additional testing and move further along. And again, that hasn't stopped. We've continued to see the improvement in materials, the improvement in processing of equipment, and a variety of areas that have helped build an industry which we are now all being able to take advantage of its growth and its flexibility and functionality. Been a lot of ups and downs, but it's definitely at least been exciting with a lot of it. So.
Yeah, no, those are a lot of great points, especially coming from what you were talking about, your first experience. That's just actually been a big part of the rest of the experience. It sounds like going through that whole process of learning what you can do in the prototype world and then seeing what you're talking about with materials and processes develop over the last 30 years. There's a lot of different things that are happening now that broaden what we can do inside of manufacturing as a whole. And I think that's a really good point you brought up is that evolution. And what do you think, has been the biggest impact of AM to the broad manufacturing industry as a whole?
Well, I think really one of the exciting things is how much everybody has tried to evaluate where they can apply the technology. We had the extrusion-based technology started coming out, and they started hitting the lower cost systems, which made it much more widely available. So now you've got this grassroots area trying to engage and embrace technology because it's economically viable for them. And then you've got these others that are larger manufacturers and stuff that were taking the technology, and now they're looking at how they can expand it throughout their operation. Now it's getting outside of just the engineering department, getting into the marketing, getting into the sales samples, now taking it beyond pre-production applications and moving it into the shop floor. And we started seeing a lot of jigs and fixtures start becoming very viable applications. And I still think that this is an excellent way for companies that are interested in getting into AM to, shall we say, develop their playbook.
Wow.
So if you start taking it and saying, okay, what are the pieces that we use low volume, and start applying additive into those areas where they don't need super structural or high wear resistance type pieces, but they still need to have unique geometries and configurations that may change at any point in time. You've got it as a manufacturing aid, which now becomes a controlled piece that you can apply to your manufacturing floor. And if anything fails, you can pull it off of the floor without having necessarily any risks or liabilities or anything out in the field. So it becomes a controlled way to get an understanding and basically a mindset of how to advance forward and find out what exactly the materials can do, what the process can do, what the technology can do, so that you can effectively apply it as it moves forward into other areas.
Yeah, knowing where to use the tool, right? I mean, it's I've heard that's said many times, and obviously for good reason. Another tool in the toolbox, but that's there's a lot that goes behind that, and actually identifying where to use that tool properly. And you've done a lot of that over the years, that's for sure, inside of different projects. It's not always the solution, but it is another way of, hey, this is a possibility that might get you to where you need to go, maybe with a new design, maybe with looking at something a little different as far as time or actually putting multiple parts into one. There's so many different things that happen inside of the value of additive manufacturing. And sometimes, if you don't know, you don't know. That's another saying out there. And that's the whole thing, is getting that message out there of where it works. And I think the more applications that we see coming out, obviously, the more things can be put into a standard practice and then be hopefully duplicated out there in different ways and different production techniques. But yeah, it's exciting to see that. And I'm sure, obviously you've had hands-on over the last 30 years of seeing that grow. And what would your advice be to like some of the manufacturers out there that would like to learn more about implementing or adopting additive manufacturing?
Well, I'll take that exact point you mentioned there. how do you understand? How do you get to learn what you don't know? You don't know. In other words, where's it going to fail? Where's it going to really succeed? And how am I going to get effectiveness? And is it going to run for 30 cycles or 3,000 cycles? How do you slowly walk into that safely and be able to identify what's going to work for you? You mentioned in the introduction, I think, 4 different technologies that we utilize just here on a regular basis. And it's not that one of these technologies is better than the other. They all have their strong points. They all have their effectiveness. It's just like you mentioned with the toolbox. Yeah, you want to have a hammer, you want to have a wrench. Can you use the wrench as a hammer? Well, maybe, but is it the best tool?
Yeah, good point.
And it's all these processes, all these systems are tools. So how do you get an understanding of what tools are going to really be the most effective for you? And I've actually said this even in a number of presentations. And I'm not trying to do this as a sales pitch. It's informative, but
sure.
Find somebody who can be a contract manufacturer for you that gives you access to these technologies, whether it's the OEM or contract manufacturer like us, whatever they're. Run a series of parts or applications through these providers and find out what technology they recommend and find out which ones of those recommendations actually work most effectively for you before you go out and start looking at, okay, let's buy one of these pieces of equipment. And the key reason for that is because every company's applications may be served better by one technology versus another. That doesn't mean you won't want to do the other technologies. It's just you may not have as much utility from them as one that becomes your core go-to, if you will. If you define that through working with somebody, now you've already developed the relationships to be able to meet those outlying applications. Because you can get a piece of equipment, put it in, start making the majority of your applications successful. And the ones that you've defined work best in the outliers, you've already got relations by which to be able to get access to those technologies and implement those solutions. One thing I've had a number of times is people will come up and say, "Oh, hey, it's been a while since we talked. We don't mean anything. We just got our own equipment, so we don't have any need for you." And we always come back and say, "Well, that's great. We can appreciate that, but so we don't have to do anything today. That doesn't mean we won't have applications in the future."
Right.
And the amazing thing is, and a lot of people don't seem to grasp this, but every piece of equipment I've seen installed winds up getting additional applications applied to it.
Yeah,
and it's
a great point.
Proximity. You're able to go and take a look at it and say, "Hey, can that machine do this?" And now you start finding more areas to apply it. Well, eventually this leads to a capacity problem. And if you've got these relations, now you already know where to go. And you get your capacity met until you define the next technology you bring in.
That's a great point. I mean, both sides of that coin, right? Being the actual contract manufacturer and also, being that end use customer, whether you have it in-house or you're working with a contract manufacturer only, there's both sides of that, developing and scaling and understanding once you do something and bring it in-house that you're going to reach capacity. And it's good to have those network of people that you've worked with to help you get to that next level. Huge part of support out there that the contract manufacturers like yourself are a huge part of supporting. I mean, there's just so much of it out there that people don't know about, like you're saying, and be able to show them from working together and getting through a project. And obviously, hey, AM, 3D printing brings you to failures a lot quicker, So
some intentional, some not.
Well, there you go, right? So we laugh because it happens, right? And it happens.
Yeah.
In regular manufacturing all the time. It's just that because of the way the iterations work, and you can count the prototype world where it started and still is, you get to see some of those things a lot quicker than you would in some of the other processes. And that's very, that's very valuable, obviously, depending upon the application. But it's great stuff. Great insight on that. I think that's a big part of what people need to know is when they're adopting is knowing that relationship needs to be there. And there's people out there that can actually show you how to walk through a technology and get the right, the right solution focus, because you could waste your time if you bring something in house and you can't grow with it, and you can't do anything with it because you don't understand what else it can do. You could waste a lot of time. There you go. So
yeah, there's a whole nother side to this that I got to say, a lot of the events that go on out there help shed light on this, but it's one of those that, and I'm not trying to downplay the manufacturers or anything like this, but if you're manufacturing a piece of equipment, your job is to sell that piece of equipment. Yeah. I don't know any of these systems that are completely inclusive and you plug that in and you don't need anything else.
Right.
Whether it's software, whether it's secondary processing, whether it's heat treating or hipping type things or machining, secondary applications. How do you understand what is the entire chain of manufacturing that you need from data to deliverable part? You may need 2 pieces to make that chain. You may need 10 pieces. And the biggest thing that I always hate to hear of is people who just dropped $500,000 or $1 million on getting a piece of equipment installed. And now they realize, oh, you know what? Yeah, the fire suppression system will not work. And you can't plug that in this building.
Yeah.
And now they're like, well, wait a second, and you've got this big asset that's now sitting there doing nothing and not contributing, because again, there's this whole chain that has to be considered before you can implement an additive system. Some of these are a lot smaller chains and a lot easier, but where do you learn what all these considerations are? And really, a lot of that, you can try and check on the web and Google and search for days and days and days and see a whole bunch of cool videos and probably some cats and things too. But where can you go to concisely learn and talk to the people who understand all these different things? That's a lot of my involvement in AMUG, my involvement in the SME F42, because it's getting all these players together, so that you can have these conversations of, should I get that piece of equipment or that one? And now you can talk with somebody, well, I've got that one. I do it because of these pieces here and this application. I have to have this. But it doesn't sound like you need that, so maybe you could look at this one. And you start getting those types of dialogues, which could really lead you to building a very effective system to apply additive manufacturing. And now you're at the point you're creating success stories in the organization, which now get fostered, and people are like, hey, I like what they're doing. They did all this cool stuff over here. What can they do here? And even we've had that happen where people will have us come in and say, hey, we're looking to do this piece here. Can you make that? Yeah, we'll have to change a few things here. We'll have to this, that. And next thing you know, we're actually making end-use parts off of additive equipment. Sure, they go into an assembly, and there's other standard components off the shelf that go into that assembly and a manufacturing process to modify, adapt, and create this new product. But at the end of the day, it is a tool to produce a solution, and it's finding where those are going to be effective and properly applied.
Great points. No, I appreciate it. You had something to add to that? Sorry, I didn't want to cut you off.
Oh, no, I was just going to say that obviously it's difficult to connect with people who understand all those different areas. So where do you meet them? It's been kind of difficult during the pandemic. It's been virtual land, but typically these conferences become that forum to be able to go take a look at the equipment, talk to the manufacturer, talk to some colleagues, and now talk to people who are using it. And you start getting evolutionary advancements. Granted, a lot of these conferences are once a year. So do you go to multiples? Do you go to 1 or 2? Or how many do you go to? Or how do you target the people that are going to the right ones so they have the right questions to ask? But yeah, getting successful adoption of additive manufacturing is critical, because the second you say, oh yeah, well, we're going to do all this stuff and we're going to take over all these pieces and make all this stuff happen, and they may not be considering the secondary processes, for example. Maybe they need to do finishing and decorative painting or something like that to get an end product. Well, some of those things you're not going to be able to really eliminate. You need somebody who can do a good paint job. Okay. I mean, how many people want to go and buy a car that has no paint on it? So,
finished product is a finished product. There's a way to get there, and depending upon the application, you have to look at certain things that are going to be in that whole wheelhouse and not just at the printer. Pre and post, they talk a lot about the digital value chain. Obviously, if you're starting out, with a computer aided drawing and then you're on the other end getting a product, there's a lot of steps that go through the manufacturing industry, and AM plays a big part in that digital thread, especially because of the way the computers are set up, with the CAD side going into, what you bring into slice inside of a machine layer by layer, then what comes out the other end and gets a lot of times traditionally manufactured, or, there's got to be stuff that has to happen to a part, depending if it could be metal or polymer. There's so many different applications that have that many different, roads to travel, basically. And it does. I think you're talking about and where you come from inside of the contract manufacturing world. I just want to say thank you for being there, because that's where the education happens, in a lot of these processes. And like you're saying, you need to have family that you work with, of people that that you can count on, basically, because that's what it gets down to. The applications get really intense, and there's so many different ways that they get split off. And if you aren't working with somebody that's been there, done that before, you do spin your wheels for a long time and can waste a lot with these large investments that might end up being paperweights if not used correctly. So, That is the big deal that happens with a lot of working with the contract manufacturers and the actual service providers out there. So again, thank you for doing that. It's much needed and a big part of the community. That's for sure.
Well, it started out because we were all doing cool stuff.
Yeah. So this is cool.
Yeah, exactly. Look at this laser dance. Wow, this is cool. Yeah. So, it started out with a lot of cool things, and it's can you take and make and use parts with additive? Yes, you can, and people are doing it. There are a lot of considerations to go through it, and that even leads right back to that area of how do you're almost looking at a cultural adoption within a manufacturing plant. You need to have the C-level understanding. Why are we dumping this much money into it, and why is it going to take so long? We typically buy a piece of equipment, we put it in, we plug it in, and within a couple of weeks of training, that thing's producing. Versus, what do you mean it's going to take a year before we're making good parts? So, if you can start with something that is controlled within your organization, whether it's in the design department, samples for marketing or sales, or manufacturing technologies, pallets or jigs and fixtures, or product preservation devices, dunnage, things like that. If you can find these areas to make it successful, now you can start to get more embrace from everybody. And you've got a lot of low-hanging fruit typically on the manufacturing side that can benefit from these technologies before you're actually going to making something that's saleable. And I'm not talking as in with the wind and the sails and out on the water. That's
sure. Yep.
Fun, but something you can actually put in a box and sell safely and have your insurance support the product liability and everything like that. But yeah, it's exciting to see some of these things, and it's challenging to try and get some people to really understand the freedoms that you have, but yet also some of the limitations, because
big time.
We're making the part and the material at the same time for most of these processes. So while your typical casting, forging, or injection molding, or even like a vacuum forming type thing, you know what the material is. You started with a known material. You just changed the shape of it, and now you've got an end part. Whereas here, you've got different, you don't have flow characteristics. You've got flow characteristics on the X and Y, but maybe not in the Z. How do you have the uniformity that you can take apart and turn it 30 degrees and it's still going to work just as effective, or won't it? So that becomes one of those areas. It's that the learning curve can become a bit of a challenge. Hence why there's a lot of work on standards these days.
Big time. Yeah. And then again, we need more applications to get more standards. So it's like that circle of life there that has to happen.
Mm-hmm.
A lot of great points you made on the way things work inside of additive manufacturing, especially with the community that's out there, the service providers, the people that are actually doing the work every day and can help those out there. But in general, when you look at the whole additive manufacturing community, what would you say defines the additive manufacturing community?
A lot of people. A lot of people who won't accept the word no. You can't do it. A lot of people who have pushed past things which, the majority of people would say, no, you can't do that. Don't even try. Just go that way with it. Whereas we've seen a lot of people say, I think I can. And we've done it. And we've made all these applications start to grow and continue to advance, and technologies. We've got small little desktop units, things that you can put at the end of an engineering department, and now they've got access to different pieces. So it's that constant, well, what if? Mm-hmm. What if I this? What if I that? People asking those questions, and we've started to develop a lot of capabilities. But really, I think one of the things with it is it's a community of people who've realized that maybe you can't do it right now, but what are the other things that I need to look at to do this? Mm. And you start getting everybody together in any of these events and forums. I see the SME as a way. My activity with the DDM Tech Group is to foster, more information getting out there. Yep. But it's how do you connect with the people that are asking the questions of what if, and how do you find the people who've already answered some of those questions? And when you pull this whole community together, you now start getting the collective growth of multiple ideas. The infamous two heads are better than one phrase. Mm-hmm. You're not talking about the parts you're making off of it. So you're not really digging into the intellectual property for the most part. You're saying, well, no, if I use this technology and I do this, I will get a good end part that I can use. Mm-hmm. And they're like, oh, really? So, this piece is the one that I'm missing. And now you get to something like the SME, where the RAPID conference or something, or AMUG, any of them, You're able to go there and say, all right, great. I'm going to go over to that vendor and I'm going to talk to them and I'm going to ask about that. And then I'm going to step over to this one and I'm going to be able to ask about that piece that I'm missing and see how these all come together. And by the time they're done with that event, hopefully they've got a new solution or a new chain of pieces in the puzzle that they can go back and make successful applications, come back the next year and share, hey, that worked great. I really appreciate that comment there. Geez, that was exactly what I needed.
That's huge. And I know that, your company Met-L-Flo has something in common with this year's SME event, RAPID TCT, celebrating 30 years.
Yes,
wow. Congratulations on that. That's amazing. And talking about the time of developing all this with the community and with the customers. As far as that 30 years ago, SME has been doing the event, RAPID TCT now. And what has your experience been over the 30 years with that event?
Well, originally it was all little desktops, tabletops. So you went, you had just a little small place, you met some people, and now it's grown to be a relatively large forum of, high-end pieces of equipment down to tools to help support it, which is nice because you're seeing this whole chain. Really, the key is it's been a means by which to go and see some talks and some presentations and get some insight of somebody's case study or go to a panel and be able to ask some questions and say, hey, wait a second, no, why did you do that? And that's one of the things one of my personal things I always love is the panels because it's unscripted. So you get to ask any question and you may not have the question that you need to get answered, but somebody else may ask it. And now you get to learn from it. And then take that knowledge that you've just gained, those little nuggets of knowledge throughout the event, and go down to the floor and start poking at the pieces of equipment that you want and seeing which ones are really going to meet up to your needs and which ones are going to fall a little bit short. Or the same reason why we keep going, so that we can offer services to people and they can come over, we can meet with them, we can catch up and talk, show them some of the new things we've added, show them some of the new approaches or stuff that we're doing. And now maybe they look at it and they say, oh, you know what? We really don't have enough applications to justify this right now. Let's work with you for a while we start developing these. And we have no complaints saying, well, hey, have you looked at applying it in this application? And have you looked at this one? And again, through that relationship, in all sincerity, we're not selling a product. We can't sell you something because it's a service. We can only be there to provide that service when you need it. But a lot of times we develop these good relationships with people and, okay, yeah, no, we don't do that. We can't help you with that. But have you looked at this? Because I've heard that was a good solution for
right. Yeah.
And now that relationship is helping beyond just creating a part. And that's one of those areas where we're able to reconnect with everybody to stay on top of what are the latest things, what are the new innovative solutions that have come out, and how we can apply them, so that at the end of the day, we're hopefully adding value to all the people we're working with.
Yes. Yeah. Big value. I mean, there's a lot in
hopefully,
there.
Yes.
Yeah. Well, you can't please everybody, but, hopefully 30 years of experience does a little something there.
Yeah. I mean, we've got pieces that are, a variety of different components that we're the manufacturer of now, which is all developed over time. Some of them straight off machines, some of them off of tools made from machines, but a lot of it is all additive enabled. So yeah, and then we're seeing more people understand how they can apply the technology, which opens up more applications, and we're seeing this change in manufacturing starting to happen a little bit more regularly, where the embrace is coming, the acceptance is a lot more engaged.
Yeah, no, it makes sense. I mean, that's the progression of this, especially what's been going on through the pandemic. I mean, there was a lot of things that 3D printed was able to get in there and, mitigate risks out there, and especially inside the health industry with breathing apparatus. PPE was a big thing, swabs. There's so many things that are happening that kind of brought up, hey, this is a supply chain issue that we could actually do something with the technology of 3D printing. So that's been a highlight. I know there's a lot of things happening this year at the RAPID TCT event. Is there something specific that you're looking forward to this year?
Oh, geez. Something specific. I'm working on a presentation with a friend of mine, and we're going to be trying to orchestrate this panel. But again, I mentioned a little bit of disproportionate towards panels. But it's one of those about how to help people get engaged and embracing additive manufacturing and getting it as one of the tools in their toolboxes. But even with this year, I think it's strange because I've been doing a lot with the FabTech event over the years, trying to bring a little bit of additive into there. Not the depth of technology you typically see at RAPID, but it's something more introductory to make sure that people who are only allowed to go to one show or whatever, and they have to pick, and this is the only one they can go to, they have some ability to get some understanding on it. So I think having both of them in the same location may provide a very, very eye-opening opportunity for a lot of those people that may be attending FabTech. They come and they spend a half a day walking the RAPID show. And again, people at the RAPID show could say, hey, you know what? I think that this manufacturer is trying to do some stuff with that, but go take a look because they had additive pieces on their equipment on the show floor over there.
Yep.
And now you're seeing applications. So not that RAPID hasn't grown a lot. Sorry, RAPID plus TCT. Not that it hasn't grown a lot, but it's still one of those that additive is not as large as a lot of other events. Sure. Nothing wrong with that. It's just growing, and it's strange, or it's strange. It's kind of cool to see how it's actually been applied in other events, but yet some of them may not even know the pieces were done additive.
Again,
they just It's another
you don't know, you don't know. And that's a great point. I mean, that show Fab Tech is happening the same week. That's the week of September 13th at the McCormick Center there in Chicago, Illinois. But yeah, the 13th through the 15th for RAPID plus TCT, and then Fab Tech wrapped around that week. There will be both those events going on, so that's something to take advantage of. But yeah, now that the events are opening back up, that's a great thing to be a part of, and looking forward to it this year. Additive manufacturing is growing, like we're talking about. Manufacturing as a whole has definitely started to adapt a lot of those additive manufacturing practices inside of the whole manufacturing solutions. So it's cool to see what's going to be happening next at a show like RAPID plus TCT. And when you're combining Fab Tech in there to get a little bit more involved in the other side of the manufacturing world. So looking forward to that. Now, we talked a bit about, what SME you're doing with SME and having the panel coming up at RAPID plus TCT. What type of role do you see SME playing, like in the additive manufacturing space in general, or what would you like to see?
Well, I got to say, there's definitely a need for connecting people with the experts that can give them the insight, the vendors that they may need to augment their solution, or the ones that they need to talk to create a solution. And it's really one of those areas that can you do it on the web? Sure. How effective will it be? It's hit or miss at that point, because let's face it, there's no BS meter on the web. So whether you're reading something that is 100% accurate, or just 80%, or
true,
if it's giving the full picture, you really don't know. Whereas an event where you can go see content, continue afterwards, and talk about that content is definitely an area. I see the RAPID plus TCT show being one of those that is great for looking at the new equipment, the new material suppliers, the software providers, and things like that. To anybody who's looking to get into it a little bit and needs some more knowledge, it's a perfect venue for that. The SME gives a good forum for this. I like how they've been able to add an additive component to the Fab Tech event, so that you've got kind of at least an introductory, if you will. Okay. So that people who need to learn more can at least learn where to learn more. But I see that the SME obviously has this platform with all of their different venues to help give awareness, to help share the applications that have been applied to those different venues. The Aerospace and Defense Show always had one. They had a lot of additive there. And additive is huge in aerospace and defense.
Big time.
It's just design consolidation, part optimization. You can't get a better.
As much as you can save fuel. Yeah, there you go. Let's do it.
Let's save 25% on every trip.
Yeah,
really?
Sounds good.
Yeah, exactly.
Wonderful business cases in aerospace, that's for sure.
Yeah. So and they're doing a great job of paving the way and developing a lot of that understanding of what is and isn't really achievable, or what's it take to make it achievable. Now, again, you're talking about specific applications they may not be able to share all the details with. Sure. But as we start to see more of these come out, we're going to see a little bit more of that information available. And as we can get more people aware of how to apply them, we're going to see a collective pool of knowledge. Now, how do you get that pool of knowledge able to be validated, shared, invalidated? I see the SME as being that non-biased kind of sounding board that should be able to promote that validation side and help people flush out the areas that are not fully accurate.
Great points. I know, we do have a lot of people, especially at the events and shows, that come from the younger generations out there, the new workforce, and there's a lot of things in manufacturing that can attract that younger generation into 3D printing. It is in itself a pretty attractive industry. But what would be your advice for attracting younger generations or the new workforce into additive manufacturing?
Oh, wow. There's a bright minds activity, or was. I'm not exactly sure of all the status on it. I'm not too engaged on it anymore. Just time commitments. Sure. The SME was actually engaging high schools and even like community colleges. The activity was to engage students in high school and community college type levels, and see what we could do to get them down to walk the floor with somebody who was an expert.
Awesome.
And they would share that knowledge, and you get insight, even though they're not necessarily buying, but they're getting aware. And the reason I bring this up is because Stratasys had actually was one of the people at the time, and they donated a machine to a school, and I got the opportunity to bring Scott Crump and his wife, who was a teacher, to this school, and just to say, hey, here's your donation, see what it's done, accept the thank yous, that type of stuff. And the school had regional education directors and a whole bunch of people, more than just the teachers that were involved. And the reason is because they saw the students wound up having a 1-point GPA average increase.
Oh, wow.
Amazing. Yeah. And I don't know what the teachers were doing, but I think it was one of those that put all the theoreticals to tangibles. I thinking about it afterwards, I'm like, well, okay, your geometry teacher. Well, if you look at that 3D printer and it does this, and how do you calculate that it does? Now they can start seeing where all these formulas and calculations get applied to actually making a part. And, as opposed to, well, did you remember everything that was in chapter 23?
Right. Practical applications are always better than just trying to pull something you haven't actually gone through yourself. So yeah, and just seeing them openly be excited about that and share some of what these students were doing, it was just cool. It was like, wait a second, we actually reached them. If we can get more engagement with academia, I think that's a huge area because. Again, we touched about it earlier. The cultural embrace within an organization is a major hurdle to overcome. Everybody's got their job. They got to get their objectives done. They got to get their things met. And oh, by the way, the family's calling because they need this, that, and that. So where do people go to learn about all this when you can educate the students on it and have them come up already with an awareness? And they say, wait a second, in my university class, we did this with this and made this work. Why can't we do that here? Great, let's do it. What do we need to do? It may shorten some of that adoption. That's important. I think that's the biggest side of it is, again, if you don't know, you don't know, so there's got to be somebody that's bringing it in front of people that need to know. And great points about everything that it has to do with our next generation there. Additive manufacturing is evolving. A lot of things have happened in the last 30 years. Coming up in the next few years, how do you see that additive manufacturing evolving in the next few years?
Wow.
Big one,
like
right?
Like a mushroom?
Yeah.
There's so much work being done on advanced materials and even on means of doing volumetric solidification of materials, where you're creating an entire three-dimensional object at once. So you've got some exciting things there that might take a little longer. But I think we're going to start to see more knowledge about where we can successfully apply these materials in manufacturing or in end-use parts. And we're going to start seeing it become more of a, I don't want to say an offering, but more of an applied solution, which will become in essence, I don't want to say a game changer, but it'll definitely become a competitive advantage for those that are adopting it and getting onto it, which will cause more to want to jump on. So we're at this, I don't want to say this fan effect, but we're basically at this area where we're going to start seeing things going in multiple directions. Mm-hmm. And it'll be interesting to see those that we haven't even conceived of yet. You look at the hybrids. The hybrids are popping up all over, whether it's machining at the same time as deposition, whether it's repair applications.
Materials. Now we're seeing even multi-material. It's interesting.
Yeah. And again, there's every application that's viable. We touched on aerospace. You think of any UAVs and how many people want to use unmanned vehicles for maintenance and recon type areas. The DDM had one of the entries I was thinking of a while ago it was a drone that would go and do investigation of bridges so they could identify if there was any structural weaknesses without actually having to go and have a person on some piece of equipment hanging around there. So quickly getting information back. Now, whether that's checking power lines or gas lines or whatever, any of those different types of areas, being able to make a UAV lighter through additive is a whole nother area that's getting a lot of development. Battery powers, there's a lot of different things. So I see yeah, exactly. I see the hybrid systems becoming a big area.
Yeah,
and obviously the expansion of materials is just something that's really growing. So.
No, that's all great stuff. I know materials are the bottom line here, but there's a lot of materials development. And we also seen the evolution of the softwares that can handle what's going on with the technology. So it's going to be interesting to see how the materials and the software and the technologies all push things forward. It's development. And we also seen the evolution of the softwares that can handle what's going on with the technology. So it's going to be interesting to see how the materials and the software and the technologies all push things forward. It's happening as we speak. So
yeah, it's exciting times.
It is exciting to be here talking with you, Carl. Thank you so much for your time today. And Carl Dekker, thank you for being a positive leader and a contributing part of the SME additive manufacturing community.
Always a pleasure, Adam. I appreciate the times we get to chat, and I totally applaud the effort of trying to get stories like this one that we just shared, get them out there so that people can hear, and hopefully we'll collectively make everything a lot better faster.
Yes, we will. And looking forward to seeing you at RAPID TCT this year and FabTech.
Excellent.
All right.
Looking forward to catching you there. All
yes.
Right.
Yeah, we'll see you soon.
Okay. Well, thank you very much, Adam. Thank you very much, Adam. Thank you very much, Adam. Thank you very much, Adam.